Hello everybody, how is it going? Before I jump into this video, I just want to talk about something really cool that has happened recently. I have been selected to be a certified trainer in Max MSP. Yes, Cycling 74, the company that made Max MSP, said I'm doing a really good job with these tutorial videos and teaching you guys, and my projects are all pretty cool, and they want to help me help you guys. So look at this. A certified trainer badge that is in all my videos now. I am so excited about this, and I think it's gonna lead to some awesome things for all of us. It'll be really cool what this certified trainer program has in store. So I'm super excited about that, super excited to share that news with you guys. And now to jump into the tutorial video where I explain what the heck you are looking at right now. Back with another Max MSP tutorial. We have been doing a beginner series for a sec, but we're going to take a break from that today to get to a really fun, cool technique to get really excited about in the future called slit-scan. I've been seeing a lot of people do stuff with slit-scan effects, so I figured I would just try it myself and see if I can make it into a simple to use, easy tutorial. And sure enough, it was possible. So here it is. Let's do it. We're going to jump right into it. First things first, anytime it comes to doing any kind of visual work in Max MSP, we're going to need a jit.world to see everything in a window. And we're always going to do floating 1 at FSA1 at FS menu bar. So we have a nice floating window that won't disappear when we click away from it. We have full screen anti-aliasing, and we have no menu bar when we're in full screen. I love those settings for the jit.world, and we're going to attach a toggle on there, click it, turn it on, and render that beautiful jit.world window so we can see things. Next, we need to create our slit that we're going to use to do the scanning. And to do that, we're going to jump into the world of jit.gen. Jit.gen is basically the object in Max MSP that lets you do stuff with shaders, and it's a really awesome, very versatile function, and I highly recommend learning everything you can about if you're interested in doing visual stuff with Max MSP, because it's your best tool for doing anything like that. And this is going to be a pretty good look into some very basic concepts of jit.gen. So to do what we need to do, we're first also going to create a jit.matrix, and we're going to say for float 32, so we have an alpha channel that is floating numbers, and we're going to say 1280 by 720 because this is the dimension size of my webcam, which we're also going to use. You may be using a different webcam, so you may want your dimension sizes to match the size of your webcam, or whatever kind of, pixel HD dimension resolution you want for your visuals. It's up to you and your computer graphics processing card. But what you're going to do once you create that matrix, you're going to patch that right into the jit.gen, and then we're going to create a sunrender object, and we're going to patch our render bang outlet of our jit.world, which is the middle outlet, to that sunrender, and we're going to create a copy of the sunrender and turn it to a receive render. So it receives that bang every single time we get a new frame, which is going to update this matrix through this jit.gen to give us our slit once we do the slit programming stuff inside the jit.gen, which is exactly what we're going to do now. So we're going to lock our patch, and we're going to double click on the jit.gen object, and it's going to open up this awesome subpatch window where we have a whole bunch, a new set of tools to do programming stuff. And if you're new to jit.gen as a concept, it can be kind of difficult to wrap your head around because it does use a new set of objects. But these objects are just different names for some of the same functions we would have in our regular our regular Max MSP domain. So once you realize that connection, it's not too bad anymore. What we're going to do first inside this jit.gen domain is delete those patch cords, and we're going to even delete the second inlet. We're not even going to use the in1, but we do need it there so we can patch the matrix object into this object and instantiate the jit.gen object as so it can do its functions. That's all that's going on there, but we don't actually need the inlet to do anything in here. Instead, we're going to generate some pixel values using a norm object. It says normalized coordinates of input matrices. What this means is it's going to create a line from 0 to 1, and if we set that into our pixel values, it's just going to be represented as like a gradient. We can't see anything in our window right now because we need to actually patch this into a, leave me alone Java, we need to patch this into a jit.gl video plane object with the @transform reset to attribute set. So it goes to the edge of our window and we can see it. And when you patch the jit.gen into it, you see, okay, yeah, we get this gradient. And what's going on? Well, it's from 0 to 1, as I mentioned. So when we set that to be the cells of our pixel, or the cells of our matrix, it changes the color of the pixel to match. So 0, for pixel values is black. But when we get towards 1, we get a nice saturated red, and that's because we are only doing this in one dimension right now, I believe. And we don't even need to worry about that, quite honestly, right now. That's for our future jit.gen tutorial. Right now, what we're going to do is we're just going to swizz out the x dimension of this norm. We have coordinates. They're going from 0 to 1, and they're going across the x dimension of our matrix and the y dimension of our matrix. And we really just want the first x dimension, which when we patch that in there, you see is now it's changed our visual gradient. Instead of going from the top to the bottom, we only have the set of zeros to 1 from left to right. So that is why it is now black to white. And because we're only using one plane of it, we're only swizzing out one plane. That's why it changed to white instead of red. It's just because we're dealing with one plane of data now. So by default, it's going to do everything in black and white with one plane of data. Pretty common for jitter visual stuff. Now you may be asking exactly what did I mean when I said we're swizzing out the x dimension. Swizz is a gen operator object that is very similar to unpack. All I did was unpack the x coordinate planes of our norm line, and that's it. It gave us this cool gradient. Now, how do we turn this gradient into our slit? That is the question. To do that, we just basically need to get a return of a very small fraction of our gradient. As I said, these cell values are just going 0 to 1. So if we turn this into, say, like a greater than 99, it's going to give us a 0 for everything that is less than 0.99 and a 1 for everything that is greater than 0.99, which when you're going from 0 to 1 is a very small fraction of that gradient. In fact, it's the very end fraction. You can barely see that white bar all the way over on the edge, but that's perfect. This is exactly what we need to do this slit. We just need to now make it move so it scans across our window, and that's pretty easy to do too. We can still do that in the jit.gen domain. We have to use this other jit.gen object called param, which basically lets us set parameters to change inside the jit.gen object. This is similar to using a variable. We just have to give it a name. So we can say something like offset, and we're going to initiate it at 0. So the offset is 0 by default. But now, outside of this jit.gen window, back in our main max patch, we can now create a message with the name we just gave for our param offset, which is now showing up in this message in our drop-down list for as a jit.gen parameter. And we can say $1 and patch it in there and patch this a number box. And we can then drag and change this value, and it's going to change the value of the offset parameter within the jit.matrix. So to make this little line here offset like we want to do our scan effect, we just have to add this value to our slit value. So we're going to do plus time, or sorry, not plus time, plus offset, because that's the name of our param, and we're going to slide that right in there. And now when we change this value, it will in fact add it to the slit. And you see that is working, except it is not it's not staying a slit. It's kind of more like a gradient wipe effect right now, if you will, or I guess it's not really a gradient wipe effect, but you know what I'm talking about. That like wipe effect that you see in all your traditional movie sequencing softwares. We want it to stay a slit. So to do that, we have to use a modulo object, which is going to wrap values around. So because everything is normalized as a float value, our max value is 1. So none of our values will go above 1. But when we add the offset into them, they actually are going above 1. So if we slide this modulo in there, it'll wrap those values that go above 1 back to being below 1. And what that will do is make that line stay just a nice small little line, because those values are wrapping around now and they're not being actually added in. So perfect, it stays a line, and we have our cool little line that we can use to start doing the slit scan effect. Now we just need to get some kind of visuals into our max patch to do this slit scan effect on, and we have to set that up. There's a lot of different ways you could do it. You know, you could bring a movie file in. For simplicity's sake, as I mentioned, I'm just going to use my webcam because it's easy. It's easy to do that. So we're going to use the jit.grab object, and that will digitize video from an external source, which is the webcam. So we're going to do that. We're going to create an open message to open that webcam, and we're going to click open. And when we do that, our webcam is now open. You can't see it on the screen, but on my computer, my webcam light just turned on, so I know it's working. And now all we need to do is multiply these values, which I'm just going to create another jit.gen object to do that with. It doesn't have to be a jit.gen object. We could do, hey, look, there I am. we could do like a regular jit.multiply object. I like using jit.gen though, so we're going to keep it in the jit.gen. We are currently by default adding inlet 1 to inlet 2, so that's why the black now got replaced with the webcam visual view. But if we multiply it, it's going to multiply it, and that we're only going to be able to see where the white space is now. And if we change that offset value, we are going to get this little line to slide right across that webcam video plane. So that's perfect. That's exactly what we need. We're making progress. Not first, I guess this is second now. We want to automate our offset line, so we don't have to keep changing that value. It's just going to go on its nice own ramp. And to do that, we are going to create a signal ramp, which is a very cool technique for creating smooth lines and automated data in Max MSP. We're going to use a phaser because a phaser ramps from 0 to 1, which is exactly what our offset needs. And we're going to turn the signal value into a numerical value with the peak amp message, because this is going to give us the maximum amplitude of our phaser signal, which is it's just going to be the max amplitude, which will be the top of that line always. So we see it is working. We're going from 0 to 1. We just need to patch that into this number box now, and it's working, but it's going the wrong direction. I want to reverse this. We're going to reverse subtract it from 1. So it just scrolls the other way now, and that worked perfectly. All right, so we have our offset going. Our line is now scrolling through our webcam video plane. We just need to set it up to do the slit scan feedback effect, which if you have seen my Max MSP jitter matrix feedback tutorial, that's the technique we're going to use right now to do this. We are going to create a jit matrix with a name, which I'm going to call scan, and we are going to give it the same values as our initial matrix. So it's going to be 1280 by 720. You may or may not need to reduce the dimension size on yours for efficiency. And once we create the name and give it the params, we're going to slide that in right at the end of our chain. So it's going to sit and it's going to get all this frame data. And we're going to copy this jit.matrix scan for float 32 1280 by 720, and we're going to add a through 0 to the end of it. So this one does not go through an output unless it receives a bang, but it is going to be receiving this same visual data because it has the same name, and all it needs to output is a bang. So we're going to create a button, and we're going to patch that button right into the top of this jit.matrix, and then we're going to create this jit.alphablend object, and we're going to on the alpha channel blend our incoming new frame with our old frame, and it's going to in fact create that really awesome slit scan effect for our visuals, and it is working. It's a little bit choppy, so we're gonna slow this phaser down so it doesn't move as fast. That might be too slow. It's kind of hard to see exactly where the line is. That can make this like not as fun, or maybe more fun. I guess that's up to your choice as an interactive design artist. But we can make it a little bit easier to understand by adding a nice green line over that line wherever it is. So let's add that in real quick. We're gonna, on this jit.gl video plane object, add the attribute at blend enable 1, and we're going to say at depth enable 0 and at layer 0. And what this is going to do is it's going to turn off the three-dimensional positioning of this video plane. It's a really weird concept. Jit.world initiates a 3D render, and the jit.gl video plane is just a 2D video plane in a 3D world, which set to the window size makes it look like it's just a 2D world, but it's not. It's 3D. So we have to tell it right now to not be 3D by saying at depth enable 0. And when you do that, you then have to use the layer attribute to specify which layer it's going to be in our new two-dimensional world that we just are trying to work in for this video plane. So we have now set that up to be the background layer, and we're going to create that little green line, and we're going to add that green line over it. So we have our slit scan effect working already, and I'm just going to highlight everything and move it out of the way a little bit with my video plane included. And we're going to copy this jit.gl video plane, but we're going to change the layer of this copy to 1, so it will sit on top. And it's turned black now because we now have a new video plane layer on top of our old video plane layer, and there's nothing in it yet, so we can't see anything, but we are going to in fact let ourselves see what this is when we create a jit.gen object and we patch that in there, and then we give this jit.gen object the line. We need it to receive this line from this jit.gen where we created it, and there it is. We have a cool little line over our line now, so it actually is already pretty nice because we can see where it is. But if we wanted to make it green for fun, we could double click into this gen and we can do some cool mixing stuff with this cool mixing object. It's actually called mix, and it has 3 inlets. The interpretation if it is 0, the interpretation if it is 1, and then the thing to interpolate. So what does this mean? Well, basically we just it crossfades 2 videos together, and then it figures out how to crossfade those 2 videos based on a 0 to 1 value. So in this jit.gen domain, we can use this object called vec, which is similar to pack. It's kind of the opposite of Swizz in that sense. And we can use this to pack together 4 values for our RGB alpha value. And we are going to, for one of them, say 0, 0, 0 for all 4 values. So that way it will be black. And we are going to patch that into the if interp is 0 input, because we want our black color vector we just made to match wherever there's going to be black in that line sweeping animation. And wherever the line is, which is white, and our 1 interpretation, we're going to instead make it be green by having an alpha of 1, a red channel of 0, a 1 in our green channel, and a 0 in our blue channel. And you can see, okay, it already turned everything green, because right now it thinks the entire channel is closer to 1 than 0. But if we send in our line video from our first inlet as our mix interpolator, wherever it is black in the line, which is not where the line is, it will be black, and wherever the line is, it will be green. So that now turns our line green, and it's still, because we're using 0 and we're doing an alpha blend, and we have an alpha channel, that 0 is the previous frame, and everything is still blending together, and we can see it, and we have this cool slit scan effect with this cool line going on, and we can see where we're scanning and everything that's going on. I'm just gonna, for fun, as like the very last thing in here, attach a float number box into our phaser so we can change the speed that this line moves at, and we'll find a good value where it's like fast enough but not choppy. Let's try 0.05. And that looks pretty good to me. So there you have it. A full finished slit scan effect. It's pretty cool. And I really enjoy this. I can play with this for hours. We could do a little bit more to maybe clean it up, but that's the homework for this tutorial, I guess. I hope you enjoyed this. I hope you guys learned something in this tutorial that you did not know before. I hope you enjoy playing with the slit scan. It's a pretty cool effect and can be used creatively in a lot of different ways. If you guys like this video, if you guys learned something, please like and subscribe. It lets me know that I am doing a good job and that you did in fact learn something from this video. If you have any questions remaining about anything, please leave them in the comments down below. I will try to answer your questions when I see them. And on that, I would also say, if you want to continue to support me, I would really appreciate you subscribing over on Patreon, where I am working on uploading exclusive tutorials. I am sharing cool art projects, exclusive in-depth early looks at some upcoming works. A lot of fun stuff is happening over there. I can even give you one-on-one max tutorial lessons if you're interested. That is an option that I recommend if you want to learn more. It's the best way to learn. And that's about it. So again, hope you guys learned something. Keep on using Max MSP, and I'll see you guys in the next video.